Hi everybody, this is the Math 10C Exponents and Radicals review, and this is short answer 29. This is the second half of the question, questions G through K, and we're just going to write these things as mixed radicals, so root 245 here. Now, right off the top of my head, I don't know how 245 is supposed to be reduced down here, but I always recommend when you're working these kind of problems that you use the prime factorization. So I can see right now that I can pull a 5 out of that. Okay, and when I pull a 5 out of that, I'm left with 49. So 245 divided by 5 is 49, and I know 49 is 7 times 7. So the way a square root works is that I take that pair of 7s and it becomes a single 7 out front. I'm left with a 5 underneath the radical I can't do anything with. And so there's my answer, 7 root 5. 384, once again, is another number that just off the top of my head, I don't know what to do with it, so I know it's going to be divisible by 2, so I'll just do that. And when I do that, I get 192. I don't know what to do with that, but I know it's divisible by 2 as well, so I take that out. And then I get 96. I don't know what to do with 96, but I know 96 is divisible by 2, so I take another 2 out. And I'm left with 48. 48 is divisible by 2, so I just keep going. I get 24. I know 24 is divisible by 2. Put another one there. I get 12. I know 12 is divisible by 2. Get 6. I know 6 is divisible by 2. And then there's a 3. Huh. Now I'm just going to double check this. 2 times 2. So it's 1, 2, 3, 4, 5, 6, 7. So 2 to the 7 times 3. Do I actually get? And I do get 384. Okay, so that is correct. So it's a square root. I'm looking for pairs. There are 3 pairs of 2's there, so I can pull out 3 factors of 2, and then I'm just left with a 2 times a 3 underneath that didn't have pairs, and this becomes 8 times the square root of 6. For this next one, 108, cube root of 108, well, okay, 108, I do recognize this is 9 times 12. Okay, and in fact, we've done this one. We did this one earlier over here. Okay, this was B here, so we already know that that's going to be 2 times 2 times 3 times 3 times 3. So this is going to be, whoops, here we go. This is going to be the cube root of 2 times 2 times 3 times 3 times 3. It's a cube root, so I'm looking for triplets, and there's a triplet of 3's, so I can pull one of those out. And then I'm left with the cube root of 2 times 2 left over, which is just 4. So 3 cube root of 4. For J, we're looking for the 4th root of 144, and I hope everybody recognizes that is 12 times 12. So now, this will be the 4th root of, okay, well 12 is 4 times 3, so both of those are going to be 4 times 3, 4 times 3. So there's going to be 2 3's here, and each 4 has got 2 2's in it, so it's going to be 2 times 2 for the first 4, times 2 for the second 4, times 3 for the 2 3's that are there. With a 4th root, I'm looking for a group of 4 factors, and there it is. So I can pull out a single 2 times the 4th root of 3 times 3. Now, there wasn't enough of those. There was only 2 of them. So I just multiply those together, and I get 2 times the 4th root of 9. And now, last but not least, cube root of 750. Okay, the joke is on me because that question was asked up here. So I'm going to change this to the square root of 750 because I can do that, and I will change that on the file there, so it will be square root of 750 when you look at it. We already know that the factors are 2 times 3 times 5 times 5 times 5. A square root means we're going to take a pair and write a single value up front, so it's going to be 5 times the square root of 2 times 3 times 5, well that's 6 times 5, or 30. And there's the answer, 5 times the square root of 30.